So 5.3 is solving trig equations. I warned you at the beginning of the week, this is a big deal, okay? The verifying and simplifying stuff, while it's a big deal that you are successful at it, this is a skill you will use a lot next year and beyond, okay? So solving trig equations, you just have to learn to treat sine or cosine or tangent like an x, okay? And solve an equation. Today's learning targets are listed here. We're going to solve equations with decimal answers. We're going to talk about when there's a finite number of answers or infinite answers. We might have to use trig trades, etc. Okay? All right. It says in lesson 5.2 you verified trig equations called identities. Okay. Now we're going to solve with numbers in them. We're going to have to find the value of x. So this says we're going to solve this equation. The cosine of x equals 1/2. Now, that equation can have infinite solutions, yes? Look at your unit circle. Where's the place that cosine has a 1/2? At pi over 3 or 60 degrees. So if I was taking answers, I could have pi over 3 plus 2 pi over 3 minus 2 pi, etc., right? You think about the graph, the value hits 1/2 over and over, okay? A lot of our questions will use this interval. They'll say basically on the unit circle, right? 0 to 2 pi. So there are two places on the unit circle that the cosine is 1/2, right? But if it says all solutions, okay, if it says all solutions, then you're going to have to say, well, these two are true and every multiple of 2 pi after that, okay? And because it's cosine, this only works for cosine, guys. But do you see that the solutions are equally on either side right here? So you can call this one pi over 3 and this one over here would be negative pi over 3. Does that make sense? So you could say this one is going to repeat every 2 pi and this one is going to repeat every 2 pi. Okay. And so by stating these two, you're really covering all of them. Most students don't do that because it just confuses them. If you look at your unit circle and find these two answers and then say it's going to repeat every multiple of 2 pi after that, that's fine. But if you get it and it makes sense to you, everybody understand that 5 pi over 3 is really the same exact place as negative pi over 3. That's why we renumbered it on our colored unit circle. So it's shorter to write this than to have to write this and this. But it's okay either way. Long as your answer is equivalent, I will take it. All right. So it says today we might have to do some trig trading. We may have to take square roots of both sides. We're definitely going to have to factor and set things equal to 0. It says quadratic formula. Thank goodness we don't have to do that today. Rewrite a single trig function. We may have to trade some things. All right. So this one is done on your paper. I just want you to watch. What can I factor out? These are multiplied together and this. What can I take out of those two terms? Does everybody see that? Okay, if I divide out a cosine here, I'll have tangent. What about back here? -1. Does everyone understand? Did I lose anybody? Okay. When you get to this spot, we use what's called the zero product property, only we never call it that. We just say, if these two things, this and this, multiply to make 0, one or the other has to equal 0. We're good with that? So the cosine is 0, or the tangent of x minus 1 equals 0, which would mean the tangent of x had to be 1. We good? Now we're going to look at our unit circle. And this particular directions say from 0 to 2 pi. That's going to be your favorite when it says that, because there's a finite number of solutions found on my unit circle and I'm done. You don't have to write plus or minus on those. Can't be more clear about that. So where is there an x value of 0 on the unit circle? At what radian measures of x? Pi over 2 and 3 pi over 2. Where is the tangent 1? Remember, tangent's not on there. You got to think about that. Pi over 4 and, right? If you put a negative square root of 2 over 2 over a negative square root of 2, tangent always is straight across, right? Has the same value straight across because it repeats every pi. All right. This is a trick question, though. I don't like this question too much. If I go back to check this, what is the tangent at pi over 2? Can you look at pi over 2 and tell me what the tangent is? 1 over 0, which is undefined. So these two get thrown away. They don't work. Okay? Because if you plug them back in, they make the tangent undefined. I'm not going to probably put that on a quiz. So these are the two solutions. Okay? And that is written out on your paper already for you. Now, if it had said all solutions, guys, instead of the 0 to 2 pi, okay, if it's a sine or a cosine, you would write whatever answer you found plus or minus 2 pi n. But if it's a tangent, the period's not 2 pi, right? The answer is going to repeat every pi n. So for this particular question, you would have said pi over 4 plus or minus pi n, and that's not right, is it? Is that right? 5 pi over 4, is that where we found the other solution? Yeah. Okay, do we need both of those? We actually don't, because they're already exactly pi apart, right? So if you said both of them and wrote it just like that, it'd be beautiful thing. It's fine. Actually, you could say pi n. But you could also just write one solution because the other one is straight across, which is pi apart from it. I know this gets confusing how you could write the, but again, if it just says 0 to 2 pi, there's no confusion. Write exactly which answers work. All right, this is the ones where you have to take a square root. It says 4 sine squared plus 1 equals 4. You would subtract the 1 and get 3. You would divide by 4 and have 3/4. Then you would square root both sides. Okay. This is sine, but you square rooted something with an x, so it's plus or minus. Square root of 3 on top, but square root of 4 on the bottom just becomes a 2. All right. Where are the 4 places that the sign is either positive square root of 2 or square root of 3 over 2 or negative square root of 3 over 2? Everywhere in the y spot. Yeah. Pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Okay. So if this directions had said between 0 and 2 pi, by the way, what does that mean that the brackets are different? Include 0, don't include 2 pi. It just means if you get an answer there, call that spot 0, right? That if you get around the second time, you don't need to include 2 pi. All right. If it said that, we would just list these 4 answers. Okay. If it said all solutions, any ideas? Yeah. I would probably have listed the first and second one maybe and said, you could list all 4 and just put a plus or minus 2 pi on the end, just so you know that that's okay. If you listed the first one, the next one is straight across. There's one straight across. And if you listed this one and said straight across, that would work. Okay. There's lots of ways to list that. You're welcome to just list all four. All right, ready to try one? Oh no, you have this one worked out for you too, right? Okay. All right, just watch. If I add this sign or subtract this sign over here, it doesn't matter. If I subtract this sine x over to the other side, what do I have over there, guys? Negative 2 sine x, and then what? Whoops. Yeah, randomly change it to a 3. Divide by negative 2, so I have the sine of x equals square root of 3 over negative 2, or negative square root of 3 over 2. This one does say all solutions, okay? So go to your unit circle. Where is this true? Negative square root of 3 in the y coordinate. I'm thinking 5 pi over 3 and 4 pi over 3. Is that right? Okay, are we done? All solutions means every possible answer. And this is going to repeat every multiple of 2 pi, right? Otherwise you just list it. Yep. If it says 0 to 2 pi, you don't need any plus or minus 2 pi's. Or pi's if it's a tangent. Okay. If it's all solutions, then you have to say it's going to repeat. And you really should be writing where n equals any integer, but I'm not going to make you do that. We're just, what? Okay, if we said this repeated every pi n, that would put it in the first quadrant, and it wouldn't be negative there. If you go in your unit circle to 4 pi over 3, if I go straight across from it, should I include that answer? Here, let me graph it. This will help. Okay, so we were asking where is it hitting negative square root of 3 over 2? It hits it here and here, right? And this answer will repeat 2 pi later because that's the period. And this answer would repeat 2 pi later, but not before then. The difference is if it's a tangent graph, the tangent has a period of pi. So if I wanted this value on a tangent graph, it's going to repeat, it's going to repeat just pi later because that's the period. Better? Yes. There are other situations where you can use it because there's other things on the unit circle, but you don't have to ever work. You can just write the longest, messiest answer. As long as it's true, I'll take it, okay? Because there are sometimes shorter ways to write things. All right. All values of x. Okay, guys, look at your unit circle. Where's the cosine negative 1? You have this question on your worksheet. The only place the cosine is negative 1 is at pi, and how often will that be true again? Every 2 pi and later. Now, your book would also just probably write plus 2 pi n, because they say because n is an integer, it can be negative. I like to put plus or minus to remind myself I can go either way. That's it. X equals, we good? All right. Then this is just tells us we should have maybe factor things. Oh, I have this example up here, guys. If it says sine squared minus sine x equals 0, what we're going to do, everybody looking, is factor out a sine, set each one equal to 0, and then we're going to say where is the sine 0 and where's the sine 1, and there's going to be some solutions. Actually, I think there's 3 solutions to that. Look on your unit circle. Where's the sine 0? 0 and pi, and where is it positive 1? Pi over 2, right? So there'd be 3 solutions. But if someone got the brilliant idea to add sine over to the other side and then divide a sine x on both sides, this would divide out to be sine x, and this sin x divided by sin x would be 1. How many solutions does that have? Just one, okay? So it says don't ever divide out trig factors, trig functions, because you'll lose solutions, okay? All right. So what we don't want to do is divide out a trig solution. What can we do with this, though? Yep, take a sin x out. What will be left? Okay, done? Oh, that factors further. Andrew recognized that right away. Because this is something squared minus something squared, right? Difference of squares, how will that factor? Sin x plus 2, sin x minus 2. Okay, now if we play the take your turn be an equal to 0 game, this could equal 0. If I set this equal to 0, I'd have the sine is equal to negative 2. If I set this equal to 0, I'd have the sine is equal to positive 2. Anybody see why that was a huge waste of our time? Because the sine can't ever be more than 1 or less than negative 1, right? Okay, so all we really got out of that disaster was that the sine is equal to 0, and you told me that happens 2 places. 0 and pi. You could call it 2 pi instead of 0 if you wanted this time, because what does it say up here? All solutions. So pick the ones off the unit circle, call them whatever you want, and then you're going to have to say what? Yes. Okay, now, just because some of you are thinking this, it would have been okay to write this. Does anybody know why? Because they're straight across from each other, right? If you started at 0, the next solution is pi, the next solution is pi after, okay? This is just a shortcut of writing this, but I'm fine with this. Everybody good? Not trying to confuse anybody. All right, what do you want to try in this one? Take out cosine, and what will be left? Okay. So we will get the cosine equals 0, or the sine equals 3, which is never true. Okay, cosine is 0. What? Pi over 2 and 3 pi over 2? Plus or minus 2 pi n. That's a fine solution. There's about 5 more ways you could write that, probably. One of them, because it's cosine, you could say, if I start at the origin, I could go up a pi over 2 or down a pi over 2, and I'd hit a solution. I could also say they're straight across from each other, right? So I could have just listed one of them plus or minus pi n. Just whatever makes sense. I don't want to, I feel like the more times I talk about alternate ways to write it, I just confuse you. I've seen people use k. Don't use x because it's already used in the problem. That makes sense? Yeah. Otherwise, I don't really care. Yeah. No. Some books I've seen use k, but that's about it. All right, what do we want to do here? This is the kind we don't want to do what? Divide. Okay. So 2 sine cubed of x minus sine of x equals 0. Now what? Take out a sine and we'll have 2 sine squared minus 1. Am I going too fast? Does this factor further? This is not a perfect square, right? Okay. So we can set this equal to 0, or this one equals to 0. Hey, do you remember earlier today I did, or we talked about this problem? Do you remember what nope, that wasn't it either. Just kidding. This one. Here was one where I showed you could square root both sides, right? I'm thinking that's what we're going to need to do here. What do you think? This happens where? Okay, which could be written 0 plus or minus pi n. But what are we going to do over here? Sine squared equals, do I need to show all the steps? How if you isolated that, what would you get on the other side? Add 1, divide by 2, 1/2. Okay. That's possible, I think, yes. Because when I square root, what am I going to get? Plus or minus, because I square rooted something with an x. The square root of 1 is 1, square root of 2 is 2. But what is that equivalent to on my unit circle? Plus or minus square root of 2 over 2? Okay, there's a lot of those on my unit circle, yes? You want to list 4 of them? Or you want to say they happen straight across from each other? Doesn't matter to me. A lot of you would list all 4 of them probably, right? Pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Why are there 4 of them? Because I have to include both the positive ones and the negative ones, right? Okay. Would somebody like to mention what they might have thought was a shorter way to write it, and I can tell you if it's okay? Yes. Yes. Because it's every 90, right? All the way around? That would work. I was thinking about this because this includes going up 45 or down 45 and then straight across. Okay? But what Andrew said was pi over 4 plus or minus pi over 2. Okay. This is fine though, guys. List all 4, put the plus or minus 2 pi in. That's I think even how the book does it, okay? They don't say you have to get all tricky. They might, I don't remember. Oh, that's not all though, right? There were 2 more solutions over here. So in other words, if we graphed this in one period, between 0 and 2 pi, there would be 1, 2, 3, 4, 5, 6 solutions, or 7 if we counted 2 pi again. Okay, a lot of solutions where it would cross. All right, can you try? Oh, yay! What's changing here that's making this exciting for me? Yeah, we don't have to put plus or minus 2 pi on anything. So how fast can we do these? Where's the cosine 1/2? Give me the 2 spots. Okay, we're done. Okay, can you isolate the sign here? Let's see. 5 minus 7 is -2. So add 2, divide by 2. Is it 1, guys? And that actually only happens at pi over 2. We good? Only one solution for that one? Sine is +1 only once. All right. Oh, still with the interval business, but this is looking funky. What do you want to do? Okay, 4 sine squared of x, tangent of x, minus tangent of x equals 0. Then what? Take out a tangent, and we'll have 4 sine squared minus 1 equals 0. So the tangent is equal to 0. Or 4 sine squared of x minus 1 equals 0, which would make the sine squared of x 1/4. What do I have to be careful of when I do that? The square root of 1/4 is actually what? Square root of 1 is? Square root of 4 is? It's just 1/2, right? We okay? But what? Yes, I need to remember that it's plus or minus because I square rooted a squared, something with an x. All right, all the spots those things are true. Tangent is 0 when what's 0? Tangent is y over x. So the what needs to be 0? The y, or the sine. Where is that 0? 0 and pi are 180. Yep, we're in radians, okay? And it would not to include, it's also true at 2 pi, but it had a soft parenthesis there. Okay? Sine is 1/2, but it's positive or negative, so there's 4 spots. Pi over 6, 5 pi over 6. How am I doing, guys? 7 pi over 6 and 11 pi over 6, or did I get that wrong? Is that right? The y value is 1/2 or negative 1/2, right, at those places? Am I good? Okay. If you don't have out your unit circle and you're not following along, it just sounds like Hofbauer's doing magic, right? I hope you're following along. I'm not magical, believe me. All right. We're still in an interval. So do this one on your own. It says all solutions, but it says all within this interval, right? So don't get confused. As long as there's an interval, we're good. We're going to have a finite number of solutions. How many is that finite number? I'm thinking 2, yes? Pi over 6, is that right? And 11 pi over 6? Okay. Because on the left side of the unit circle, the x is negative, right? And we can only have positive here. All right. Could I call this negative pi over 6? Because I was maybe using my colored unit circle. Could I call this negative pi over 6? It says it has to be between 0 and 2 pi. I can't call it negative pi over 6. That name doesn't fall in that interval. All right. This says, blah, 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 blah. Be sure to check all your solutions, make sure they're valid. Okay, we haven't been doing that, but okay. I would not put one like this on the first quiz we do. On the next quiz I may. We're going to have to do some trades. Okay? We're going to have to trade so that we don't have two different functions here. What can we... I don't think there's a trade for 2 sine squared, or 2 tangent squared. But is there a trade for a secant squared that maybe has a tangent in it? Can you look at your Pythagorean identities? Secant squared is what? 1 plus tangent squared. Now, what are we going to have to be careful of? There's a negative out there, right? So we're going to have a mess here. We have 2 tangent squared of x minus that trade plus a 3 equals 1 minus 2 tangent of x. I kind of want to cry. That's a lot. All right, so do some algebra. 2 tangent squared, distribute the negative. I don't know, how about if I subtract 1 from both sides? And I'm going to add this over to that side too. Does that look right? I just maneuvered some stuff around. Now what? Simplify this side, and what do we get? These combine to be just 1 tangent squared plus 2 tan, right? Minus 1 plus 2 is plus 1. Okay. We're eventually going to have a lot on the quiz where you have to factor. This factors how? We're not taking a tangent out. There are 3 terms this time. Okay? Tangent times tangent will give us the tangent squared, right? Plus 1 and plus 1. If we FOILed it back together, we'd have 1 and 1 is 2 tangents. If that messes with you, just go over here and write like n squared plus 2n plus 1 would factor like this. And then, oh yeah, that would be, you know what I'm saying? If it's messing with your mind that there's words in there, just trade it out for something easy. Okay, so if this is equal to 0, what happens? Tangent x equals -1. Okay, they made this as hard as they possibly could because the tangent is the hardest one to do, right? It's not on our unit circle. But where is the tangent -1? It's got to be at those pi over 4s, right? But where 1 is positive and 1 is negative. 3 pi over 4 and 7 pi over 4. Now, you know what? They want us to try these to test the answers. I don't want to test the answers. The easiest way to test the answers might be to graph it on your calculator and make sure there's 2 solutions. Okay. What did they say? They both work? I don't think I'm going to give you ones where the answers you get don't work. If I do, I'll warn you ahead of time that you should check your answers. How's that? Deal? Okay. Speaking of which, do you have this worked out for you? Does it say after the end here that something doesn't work? It doesn't say that? Because I don't think this works. Okay. I'm going to start this problem at the top. It says find all solutions of 1 plus cosine equals sine. That's not a Pythagorean identity because there's no squareds. Does everybody see that? There's also no way to make that look nice. There's no way to trade anything for that. Their suggested solution is to square both sides. On the right, you just get a sine squared. On the left, remember we have to FOIL that out? Okay, Batman and Robin? Yes? Remember my meme? A plus B quantity squared does not equal A squared plus B squared, Batman, right? There's a 2AB in the middle. Okay, so they FOILed this all out. Then let's see, they added this cosine squared over to this cosine squared and got 2 cosine squareds. There's a plus 2x. Oh, look, they subtracted 1 from both sides and got rid of that. Then they took out a 2 and a cosine. Then they set this one equal to 0 and this one equal to 0. Okay, look at your unit circle for me. You looking? Cosine is 0 happens where? Pi over 2 and 3 pi over 2, right? Okay. The cosine is -1 at, cosine is -1 at pi, right? Okay. This is my question. Okay. If I go back, tell me what, I'm trying pi over 2 right now. What is the cosine at pi over 2? What is the sine at pi over 2? So I'd have 1 plus 0 equals 1. That seems good? Okay. Now let's try pi. If I try pi, what's the cosine at pi? And the sine at pi? Right? 1 plus -1 is 0? But this is my question. They didn't bother to check their own answers, I think. What is it 3 pi over 2? Cosine is and sine is 1 plus 0 negative 1? No. So I think that one doesn't work. Because the other thing is what I did, guys, what I did was I thought about this left-hand side as a cosine graph shifted up 1. Is that true? 1 plus cosine. So I graphed that in red. I just shifted the cosine up 1. It would actually be higher than that. It would go. Okay. Like that. The sine of x, right, just goes from 1 to negative 1. So how many times do the red and blue lines intersect before we get to 2 pi? Twice, here and down here, right? Okay. Do you want me to do it on the calculator? They're wrong. Doesn't work at 3 pi over 2. Okay, moving on. Oh, that's one we just did. We're not going to do it. Okay. What are we going to do here? Square root. Okay. Which is tangent equals what then? Plus or minus 1. Okay. Tangent. What kind of ordered pairs am I looking for here? I'm looking for this, or this, or this, or any combination thereof, right? So the answer is pi over 4. It says all. So 3 pi over 4, 5 pi over 4, 7 pi over 4 if you wanted. You could put 2 pi in, but it's a tangent. Aren't they straight across from each other anyway? So I probably would have just said 2 of them. But if you put plus or minus 2 pi in and listed all 4 of them, it wouldn't be wrong. Is that going to check? Okay, what's the tangent at pi over 4? And you square it, you're going to get a 1, right? The tangent at 3 pi over 4 is negative 1. You square it, you're going to get a positive 1. Yeah, these all work, however you want to write it. All right. Can I do this? I didn't put one of these on this first quiz, but eventually you will see a question like this where you have to trade. Can I trade a plain cosine for something with a sine? No, but can I trade a sine squared? A sine squared could become what? 1 minus cosine squared. Now, what does this sine squared have going on? It's got a 2 out in front of it, right? Can I move the 1 over to this side at the same time? I'm going to have to make it equal to 0. Okay. Well, I'm not sure that was a good plan. All right. Anyway, I'm going to distribute the 2. So this 2 and this minus 1 are going to add together and become a plus 1, right? Would it be okay if I like multiplied through by a negative 1 so that I got rid of this negative 2 cosine squared? I don't really like that. So it'll become a positive 2 cosine squared plus the cosine of x minus 1. It's the same as if I'd moved everything to the other side, guys. And I did that because I hate factoring with a negative out here. Okay, so come up here for a minute and go 2n squared plus n minus 1. How would that factor? We good? 2n and n, 1 and 1. Let's see. We need this one to be positive and that one to be negative. Would that work? Somebody FOIL this back together. Did I factor it right? Okay, so what's that going to look like with the word cosine in it? And cosine plus 1. Okay. Take your turn being equal to 0. This will say the cosine is 1/2 or the cosine is -1. Okay. All values of x. What does that mean? I need to throw some plus or minus junk on the back, right? Okay. Where's the cosine 1/2? And? Okay. Anybody know a shorter way to write that? Because it's not straight across from, we could have gone a positive pi over 3 or a negative pi over 3 and then 2 pi in after that. Oops, that's a mess. That's just a shorter way to write it. What about cosine is -1? That only happens where? Pi plus or minus 2 pi, right? Doesn't happen straight across from it. You got to go all the way around again. Yeah, I don't know. You need to write the n. Okay. We're good? Do I really want to do this one today? How about we do 14? Last one, okay? 14. What's happening here? Take out a cosine. What's left? Square root of 3 tangent of x minus 1 equals 0. So the cosine equals 0 or what? I'm not even going to rationalize that. Because on my unit circle, this is a y and this is an x. That means I'm looking for a y and an x that looks like this, right? Okay. Or both negative, yes. So, ooh, yay! 0 to 2 pi. Don't need any plus or minus anything. Where's the cosine 0? Pi over 2, 3 pi over 2. The tangent looks like this. Pi over 6. Or both negative, which would be 7 pi over 6. Okay. It says check all solutions. Actually, this is possible. Where is this true, guys? Look at your unit circle. It's not as hard as it seems. It's just a pain in the neck to figure out where it's true. But sine and cosine are equal at pi over 4 and straight across where they're both negative at 5 pi over 4. Okay. All right, guys, I have copies. These are the questions you need to be doing tonight. Here's copies. I did move the homework check to next Tuesday because I'm worried about you getting remediation done for Friday's in-class retake. The possibly snowed out in-class retake. Does anybody hear we're supposed to get a lot of snow Thursday night? Yeah. Well, if we don't have school Friday, I don't know that there's going to be an in-class retake. I'm just telling you. What? No. I'm worried there's not going to be.